Here is another age problem for us. In January of the year 2000, I was one more than 11 times as old as my son, William. In January of 2009, I was 7 more than 3 times as old as him. How old was my son in January of 2000? As usual with this kind of question, what we want to do is set up a table. So you will see on my table here, I have me, and we have Will. We have the 2 times that are mentioned in the question, 2000, 2009, we put those in the table as well. So we're going to start filling that out. It really seems like everything is given in terms of Will in 2000 and the year 2000. So we're going to set that equal to X. Now, me, in the year 2000, I was 1 more than 11 times as old as Will, who's X. So it's 11X plus 1. Now before we read ahead in the question, we want to say, can we make expressions for 2009 without more information? And we can. In order to get it to be 9 years later, we're just going to take those 2 expressions and we're going to add 9 to them. Of course, this one here we could simplify as well. This is what we have. So we have some expressions. We have an expression for me in the year 2009. We have an expression for Will in the year 2009. But we need more information if we're going to do something with it. So let's go back to the question. Here's the expression for me in 2009. Here's the expression for Will in 2009. But I know something about the year 2009. I was 7 more than 3 times as old as Will then. And that gives me an equation that I can then solve. So let's go ahead and solve this equation. Hopefully by now we know how to solve these kinds of equations. The first thing we're going to do is get rid of these brackets. We don't like them. We're going to use distributive law. We're going to leave the left-hand side the same. So just copy everything down nice and neatly. Hopefully you can do it neater on your paper than I can on the iPad. And we will distribute this. So 3 times x is 3x, plus 3 times 9 is 27. And don't forget about that plus 7 at the end. It's still there. So now we can shuffle all of our variables to one side and all our constants to the other. What we're really doing is adding the opposite. But the 3x on the right side will be a negative 3x on the left side. On the right side we still have 27. We still have 7. And the plus 10 that's on the left side, when it moves over to the right side here, it is going to flip its side. And what we're really doing is subtracting 10 from both sides. So, how many x's do we have? 11 take away 3 x's is 8 x's. And we can collect the constants on the right-hand side. 27 plus 7 is 34. Take away 10 is 24. Now we have 8x equal to 24. We'll divide by the coefficient to get a single x, just so those will cancel out for us. And x is equal to 3. So now we have a solution. Let's go from that solution back to an actual answer. Here's our original chart. X is equal to 3. So Will's age in 2000 was 3. That is in fact what the question happens to be asking for. So in January of 2000, Will was 3 years old. If you wanted to, you could plug in 3 to all these places and confirm that the original statement works, but that would be a job for another lesson.